Great. This recording now. 6.1 graphs of the sine and cosine functions. Remember, guys, yesterday I showed you that if we work using the unit circle, it is possible to associate the angles measuring radians with the value of the trigonometric functions, right? So it is possible to come up with this function y equals sine of x, for example. Now we are going to graph this function y equals sine of x. I will show you how. Well, if we start with the unit circle, the radius should be 1, right? 1, 1, 1, 1 here. And quickly we can get the coordinates of these important points. For the angle 0 radians, the coordinate should be 1, 0. For this y0 here, right? So therefore, if you go to the graph, sine of 0 should be the second coordinate 0, right? 0. So here, first point of our graph. If we continue counterclockwise, we're going to reach here 90 degrees, right? Or equivalently pi over 2, pi over 2. So pi over 2 here. And the coordinates of pi over 2 here should be just 0, 1, right? 0, 1. Now remember, in the unit circle, the second coordinate gives you the value of sine. So sine of pi over 2 should be just 1, right? 1. So the second point, the one associated with pi over 2 radians should be 1. So here, 1, right? Let's say this is 1. Great. If we continue counterclockwise, we are going to reach pi here, right? Pi. And pi has associated to it these coordinates, -1, -1, 0, right? -1, 0 here, pi. So if we look at the second coordinate is 0, that should be the sine of pi, right? Sine of pi 0. So we have associated to pi this value for sine of pi 0. Great. Continue counterclockwise. We're going to reach this point, which should correspond to the angle in radians 3 pi over 2, right? 3 pi over 2. Which is 270 degrees. Now, the coordinates of this point, since we're working on the unit circle, should be 0, 0, -1 now, right? -1 here. So if we look at the second coordinate, now is -1, that should be the sine of 3 pi over 2. So 3 pi over 2 in our graph should be associated with -1. Let's say -1 is here. So there, I'm gonna have this guy, right? Down here. Great. And finally, 2 pi, since we are back to 0 here, 2 pi, we'll have the same trigonometric function at 0 degrees, right? Because 2 pi and 0 degrees are, or 0 radians, right, are coterminal angles, right? So 2 pi here. Coordinates 1, 0. We look at the second coordinate, that gives you sine of 2 pi 0. So here 0. Okay, great. So now if you connect these dots that we have with a smooth curve, and a smooth means no corners, no gasps, right? More or less, you're gonna get something like this, right? Something like this. Continue here. So it's gonna look like a wave, right? Like a wave here. Great, great. And we're gonna call this a wave, right? Turns out this sine function serves to model, for example, sound waves, right? It serves to model sound waves, for example, right? You know that sound travels following this trajectory, right? If you want to confirm that, if you throw a stone on a still lake, you will see the waves there, right? That's because the sound is traveling, following this path, this shape. This is what physicists have figured out, right? So it's a very useful function. And not only that, it also serves to model cycles, things that repeat themselves. Because notice that if I continue graphing, the same shape will appear to the right and also to the left, right? So this should be enough for us to understand the shape of this graph, because it repeats itself to the right, repeats itself to the left. Okay, so mathematicians started to give names to the main features of this graph. For example, notice that this graph has a maximum value of 1 and a minimum value of -1, right? -1. So this is what mathematicians call the amplitude. This and this. So basically, you see this middle line, let's call it middle line. From the middle line, how high you can go? 1 unit, right? Up. From the middle line, how low you can go? 1, 2, right? So this is what mathematicians call the amplitude of the graph of y equals sine of x. Now, also important to measure how many units it takes for the graph to repeat itself, right? To repeat itself. So mathematicians figure it out. Clearly, this should be 2 pi units, right? 2 pi units. And this is what the mathematicians call the period of the sine function. Period is the number of radians it takes to repeat itself for the graph, right? So basically, we're saying here that the period of the sine function should be equal to 2 pi radians, right? And the amplitude should be equal to 1, right? Because again, from the middle line, 1 up, 1 down. Now, for you to really understand these guys very well, I have this animation. You have access to this through our website. It's under, I'm gonna put it there under useful links. I think it's not there yet, but I will put it there. In the meantime, here is the link. Let me give it to you. Yeah, I strongly recommend you to play around with this animation from GeoGebra. Look, we just said, right, that the sine function can be graphed. How? Using the unit circle. Basically, we said that if you start at 0, sine 0, but if you move along the unit circle counterclockwise, look how this vertical coordinate, which represents sine, the value of the sine function grows, right, increases up to 1 here when it reaches pi over 2, right? Reaches a peak, a mountain. Then you continue, it decreases. You can see, right, the vertical coordinate, right, the y coordinate decreases down all the way down to 0 when we reach pi, right? You see, pi. And then if you continue, you're going to decrease negatively, right? Negatively until you reach this lowest point for the sine function associated to 3 pi over 2 angle in radians, right? -1. And after that, it starts increasing negatively back to 0 to complete a cycle, right? To complete a cycle. And that's enough, because if you continue, you're going to repeat the graph itself, but to the right, in this direction, right? So it's enough to show what happens over a period, right? A period. There we go. Yeah, and again, I strongly recommend you to play around with this. You can erase this and then start the animation and kind of get this in your mind, right? That the sine function, when graphed in its basic form, looks like a wave, like this wave, right? And repeats itself, as you can see, right? To the right, to the left, again and again and again, if you continue, right? Yeah, very important to make that connection between these two. All right, now let's see. Let's take a look at the other main graph that we're going to talk about. Is the one that corresponds to cosine function. This was for sine. We're going to call it a wave, right? A wave like this, right? Now let's see what happens when we graph the cosine function. To graph cosine function again, I start by saying, okay, since I'm working with a unit circle, this should be 1, this should be 1, this should be 1, the radius is 1, right? And if I start at 0, 0 is here, 0 should be associated with these coordinates, right? The coordinates of this point, 1, 0. So cosine of 0 should be what? Anybody could write in the chat, what should be cosine of 0? By looking at the coordinates, remember the hint, the first coordinate give you sine, the cosine, sorry, the second coordinate give you sine. What should be cosine of 0 degrees? Excellent, Jingjing, right? You pay attention to the first coordinate now, right? This guy, 1, right? So cosine of 0 degrees, surprisingly, not 0, 1, right? 1. So we start there, 1. So if we say that this is 1, cosine of 0, 1, right? 1 starts there. Now we go counterclockwise, we reach 90 degrees here. This is pi over 2 radians, right? Pi over 2. And the coordinates of this point is, or are, gonna be 0, 1, right? So what should be cosine of pi over 2? Anybody in the chat? Cosine of pi over 2? Hint, look at the first coordinate, right? Cosine of pi over 2. Yeah, cosine of 0 was 1, but cosine of pi over 2. I see. Yeah, very good, Jingjing. 0, right? 0. Look at the first coordinate, right? Remember in the unit circle, first coordinate cosine, second coordinate sine. So cosine of pi over 2 has to be 0, 0, 0. All right? So we're going to mark this point now, 0, 0. Next, we continue traveling along the unit circle counterclockwise until we reach pi, right? Pi here, pi. The coordinates of this point that determines pi radians are -1, 0. So cosine of pi should be equal to the value of the first coordinate, right? -1, cosine of pi, right? -1. So we have to go now here and associate pi or pair up pi with -1, right? -1 here. Let's say here. Great. Now we continue traveling counterclockwise. We reach this guy 3 pi over 2, right? 3 pi over 2, or equivalently 270 degrees, 3 pi over 2 radians is this point. The coordinates of this point are 0, -1. I am looking for cosine of 3 pi over 2, right? Cosine. So I gotta look at the first coordinate, right? First coordinate in the unit circle gives you the value of cosine. It is 0, 0. So this guy, 3 pi over 2 should be paired up with 0, 0 there. And finally, 2 pi. If you continue traveling counterclockwise, you go back to 0, right? This is 2 pi, right? Coterminal with 0 radians. The coordinates are 1, 0. So for cosine, you look at the first coordinate is 1. So cosine of 2 pi should be 1. So up here at this level, right? So 1 there is, there we go. 1, right? Now, if we connect these dots carefully with a smooth curve, right? Avoid corners, avoid sharp turns, just smoothly connect these guys. Turns out the graphs of this trigonometric function sine and cosine are smooth. What I got? It looks like the horn of a bull, right? Or it looks like a curvy V, right? So let's give it a name so we can remember this. I would say curvy V. Curvy. Like a V, but curvy, right? Smooth. Great. Now, after that, it will repeat itself, right? To the right, it will repeat itself to the left. That's why mathematicians they stop there. They just show what happens over what we will call a period, right? But before we go over that, let me call this middle line, it's a reference, right? And then how far you can go up from the middle line, 1 unit, right? 1 unit up here. And how low you can go from the middle line down here in this direction, 1 unit also, right? This is called the amplitude. Amplitude. And how many radians it takes for this function cosine to repeat itself, that is what mathematicians call the period, right? Period. Right? Make it a little bit shorter there. Yeah, so the period should be this. Now, therefore, we're talking about period equal to 2 pi radians, period equal to pi radians, right? Or just 2 pi. Remember, you are allowed to drop radians, and the amplitude equal 1 unit, right? 1 unit, because farther you can go up or down, 1 unit. Very good. Now, even though these two shapes are kind of different over a period, there is some relationship between these two. I will show you next. But before we do that, in order just to remember this wave shape and this curvy V shape, let me show you this. Somehow, for the sine function, you start with an intersection here, right? Then you go to a maximum point, go back to intersection 0, right? Minimum point, and then back to intersection, if it helps, right, to remember this wave. For the cosine function, instead, you start with the maximum value of the function down to an intersection, minimum value of the cosine function, back to 0, intersection, and then back to maximum, right? So maximum, intersection, minimum, intersection, maximum. And this one, intersection, maximum, intersection, minimum, and then intersection again. Very good. And now, for you to associate, to link these two, let me show you again the animation that I will post in our website, and their useful links and their course materials is this. This time, let's use the cosine function, okay? And then let's do what I did with a sine function. Look, for 0 degrees, cosine of 0, 1, right? Starts at 1. Then as you move counterclockwise, notice cosine, since cosine is the first coordinate, notice how it's decreasing in length, right? In length is decreasing. So it's decreasing positively down to the 0, this point 0, right? No x coordinate, 0 x coordinate, right? So you reach this point. If you continue going counterclockwise, then it continues decreasing negatively, right? Until it reaches its lowest value here, look, -1, right? Then if you continue, notice, it starts increasing, right? The x, but negatively, right? Negatively increasing, negatively until it reaches this point, 0 again, right? And then from here to here, from 3 pi over 2 to 2 pi, continues increasing until it reaches its maximum value, 1 again, right? So you see the wavy V. There we go, right? Try to link these two. And again, I strongly recommend you guys to play around with this at home. You can erase this and then play this animation. Look, very nice animation. What happens over a cycle for the cosine function, right? You get this curvy V that will repeat itself to the right or to the left, right? Mathematicians show just what happens over a period. That should be enough, right? Great. Okay. Very good. I send you the link of this, right, in the chat. So just play around with that. Now, I talk about a relationship between the two, right? A relationship between these two. Well, if you go back to animation and we now use both sine and cosine, and we start from here, notice the relationship. Graph both at the same time, right? Notice, not hard to see, right? When this is 0, this is maximum. When this is maximum, this is 0, right? And vice versa. Minimum, this is 0, right? So not hard to see that if you continue graphing, this guy is a shift of this guy, right? A horizontal shift, to be precise, right? To be precise. So they can be put together by applying a horizontal shift. And not hard to see that that horizontal shift should be pi over 2, right? If you shift this graph pi over 2 to the right, you will match that graph with the other graph. In order to see this clearly, it's going to be important. Look at this. If you graph y equal sine of x is this, right? A full graph, right? This is one cycle and then repeats itself to the right to left. Now, if you graph y equal cosine of x, you get the other one, right? Starting at 1, down 0, minus 1, 0, 1, right? But if I apply a shift to this guy, look, a shift of, I want this to be moved pi over 2 units to the right. So I have to write minus pi over 2 right, then perfect match, right? You see, they match. So these two graphs are horizontal shift of each other, right? They're sort of parallel to themselves horizontally, right? It's a good thing to notice. I'm gonna write it here, right? And play around with your Desmos grapher and sure that you understand that. These two, is gonna help you in homework. Horizontal shift of each other. Horizontal shifts of each other. Very good. Yeah. Yeah, great. All right, moving on, guys. Now, I want you to practice first, right? On this main shape first. We're gonna go to the worksheets quickly, and then I will talk about variation of those main shapes. Try to do this. It's not that difficult. First exercise. Try to pair up the numbers here 1, 2, 3, 4 with the graphs A, B, C, and D. And once you do the pairing, you are supposed to choose the right pairing, right here, the right pairing. Maybe I can show this to you so you can do the next after we do some work. But for example, right? Maybe I can do one of them and then you can continue. This one, number 1, y equals sine of x. This graph, if you look at the 4 graphs here, is clearly the one that shows a wave over 0 and 2 pi. So it should be this, right? I see students already figured this out. Jing. Great. Excellent. Very good. Yeah, very good, right? Y equals sine clearly has to be this, for example, right? This guy. Look at the wave over a period, right? From 0 to 2 pi. 0 is here. So this should be definitely y equal sine of x, right? That's it. But this tells me that the graph 1 should be paired up with C. One with C, both with C. Now, I took care of this guy, right? Now, number 2, y equal cosine. Y equal cosine. Remember the curve V over a period, right? So number 2, where is cosine here? Well, not hard to see that this should be cosine, right? It starts at 1, 0, then minus 1, 0, and ends at 1, right? The curve V. This is y equal cosine of x, right? So guys, here, this should be 2. Can you figure out which is 3 and 4? There is a minus there, right? So you may use the reflection, right? Use reflections and figure this out. So far, we have determined that one goes with, just for our constructing our answer, right? One goes with C, then two goes with A, but then what goes with three? See? And if you have all the right sequence, then you should be able to find the answer, right? So three goes with some other letter there. Yeah, three. Aha, very good, Savannah. Very good, very good. Excellent, excellent. Yeah, notice for three, I need y equal negative sign. This is sine. If you take the negative of this sign, you have to reflect this graph over the x-axis, right? So in the end, you will get something like this over the x-axis. And that should be this, right? The reflection. Excellent, excellent. Yeah, very good, guys. So this should be the graph of y equal minus sine of x, right? Reflection of this here, right? Very good, very good. So this is telling us that for the number 3, we should consider B, right? And the last one, y equal minus cosine, has to be the reflection of this y equal cosine, right? So it will be this positive piece comes down here as negative, this negative piece positive, and vice versa, something like this, right? The V, the curvy V, but reflected over the x-axis. So you get this guy, right? Yeah. Very good, guys. Look at this. Over a period enough, right? So this will be y equal minus cosine of x. So the graph D should be paired up with 4, right? 4 goes with D. This sequence of pairings, perfect match with this, right? So this should be the answer. Follow, guys? 1C, 2A, 3B, 4D, right? Yeah, very good, very good. Great. Okay, so now we deal with the basic graphs of y equals sine of x, y equal cosine of x. Now let's try to generalize this. Let's try to go over graphs that are variations of these basic forms. In general, it says, if they ask you to graph something like this, y equal a times sine of b times x, or y equal a times cosine of b times x, where a and b are real numbers, b bigger than 0, you may say, Professor, what if b is negative? Well, I showed you yesterday how to deal with the negative sign of the angle, right? So that shouldn't be a problem. So assume b is positive. Then the amplitude, mathematicians have discovered that is always equal to the absolute value of this a. The amplitude is the absolute value of a, okay? So here, amplitude, absolute value of a. Period 2 pi over this guy b, okay? So 2 pi over b, that's the period. So how you use this? Well, imagine, right, they say graph y equal 3 times sine of twice x. Well, quickly you should identify the value of a. Notice a is this number from, so it has to be just 3, right? And the value of b is the number attached to x, 2, right? And you follow the formulas, right? Amplitude should be, according to the formula, the absolute value of a, which is 3, right? 3. So absolute value of a, 3, is just 3. Great, that's the amplitude. And the period should be 2 pi over b. 2 pi over b. B is 2. So 2 pi over 2, canceling this 2, this is just pi, right? Pi is the period of this graph. Now they say graph, right? This. Once you have the amplitude, the period, guys, it should be easy to graph. Well, how you graph it? Well, notice since the amplitude is 3, from the middle line, which is here, right? From the middle line, this horizontal line, go up 3. So 1, 2, 3, right? 1, 2, 3, up 3, and down 3. 1, 2, 3. -3, right? There we go. So go up and down wherever you get for the amplitude, okay? And then use the period to see where you're going to stop with the graph of this function over a period, right? This is pi. So somewhere, guys, set pi, somewhere. The graph will use some scale on the x-axis, so just put pi somewhere there, right? What it matters is the main shape, okay? So feel free to use any scale on the x-axis, any scale on the y-axis, okay? Now, after you set pi there, then you can see that your graph will live inside this strip, right? Cannot go farther than 3 in this direction, cannot go lower than 3 in this direction, right? So it will be inside that strip, and at pi, it will end, right? It will end here. So maybe draw this rectangle as a reference. Okay, great. Now, there are gonna be 4, technically 5 points, important points, right, that we're gonna set. Those 5 points will divide the graph in 4 parts. So otherwise, once you set pi here, immediately set the middle point somewhere, right? So now the middle point should be this. Somewhere set the middle point, it will help you. Then subdivide this into 2, somewhere there, for example. Subdivide this also into 2. Again, you don't have to be precise. It's just a sketch, right? And then start, right? They say graph 3 sine of 2x. So you are dealing with sine. And we know that sine, remember, it starts at 0, sine of 0 is 0. And then you have to graph this wave, right? This wave goes up to a maximum point, goes back to 0, minimum point, and then back to 0, right? Follow, guys? So then you just connect the dots with a smooth curve. Like this. Avoid corners as smooth as possible, right? And then you are done, right? We are done. Again, if it helps, this is intersection where you start. Then we get into maximum point, intersection again, minimum point, and intersection again, right? And then I stop there because if I continue, this will repeat itself to the right, repeat itself to the left. So enough showing what happens over a period. Now, sometimes students ask me, right, Professor, what are the values of these x coordinates here, 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 right? This is clearly 0. And the last one is pi, right? At the end of the period. But what is this? What is this? What is this? If you're interested in getting those points, guys, you can average these two, 0 and pi, right? It's pi divided by 2, pi over 2, the middle point, right? This, right? And then you can continue averaging these two. 0 plus pi over 2 is 1/2 of pi over 2, 1/2 of pi over 2, pi over 4, right? Pi over 4. Now this is 1/4, 2/4, 3/4. 1/4 is pi over 4, so 3/4 with 3 pi over 4, right? You follow? It's possible to find this middle points, right? Either averaging them or playing around with the quarters, right? 1/4, 2/4, 3/4. It's possible, right? But probably would be enough with the main shape, right, for you to identify your answer. So take that into consideration. All right, great. So example 2, let's do one with cosine. Suppose they ask you to graph this in general, y equal twice cosine of 2 theta. Well, first step, identify A, identify B. If you identify A is clearly 2 here. B is clearly 2 as well. Amplitude is absolute value of A, but A is 2. So absolute value of 2 should be 2, right? This is the farther you go up, the farther you go down. Period is 2 pi divided by B, but B is 2. So 2 pi divided by 2 is just pi. You have the amplitude 2, period, pi. So amplitude 2 tells me that from here, from the middle line, I have to go up 1, 2 now, raise 2, and down 1, 2, right? 1, 2, negative 2 here. Then horizontally, I have to go up to pi. Let's put pi here. Put it somewhere there, right? Pi. Now draw this horizontal line sort of to determine how far you can go in that direction up, how far you can go in that direction here down. Vertical line here. Inside this rectangle is going to be your graph, right? Now divide this rectangle in 4 equal parts. The half should be probably here, right? Subdivide this rectangle into 2, perhaps here, right? Subdivide this rectangle into 2 parts, perhaps here, right? And try to recall the shape of cosine function. Remember, the shape of cosine is like a curvy V, right? Look like a horn of wool, right? So it starts, remember, here at max, then intersection, mean, intersection, max, right? Look, curvy V. After you set the point, just connect these guys with a smooth curve. Smooth. So avoid sharp turns, and that's it. This would be a good representation, right, of the graph of this particular function. So now, again, right, if you're interested in finding the middle points, we know that this is 0. So between 0 and pi, average pi over 2. Between these two, average 1/2 of pi over 2, which is pi over 4, right? 1/4 is pi over 4, 2/4 here, 3/4, 3 pi over 4 here, right? And there you have the points, you have the graph, right? And again, if it helps, guys, cosine starts with max, always. Max, then intersection, mean, minimum value, intersection, 0, right? And then max, ends with max, right? So there you go. All right, now let me give you an exercise. Now that we have more knowledge, let's try this one now. Can you try this? Maybe some time because you have to identify at least 3 graphs, right? Let's start with this sine of 3x, right? Try to figure out how it's gonna look like by figuring out the amplitude and the period, right? The period. Maybe I should start this off, right? Maybe let me show you y equal sine of 3x. There is an invisible one here, right? So amplitude should be absolute value of A1, 1, A1, B3, right? And amplitude, right? And period should be pi multiplied by 2 divided by b, but b is 3, so this, right? So approximately. So with this period and this amplitude, try to figure out which is 1, and then do the same with 2, and so on, right? Try to figure out the right parent there. I see. Good, Jing, very good. Savannah, good, good. Good, guys, good. Very good job. Yeah, it's not that difficult when you look at the amplitude, probably, right? Yeah. Yeah, very good. Let's say this guy, right? Where is this graph? The graph of y equals sine of 3x. Amplitude 1. So I gotta look for the graphs having amplitude 1. This one is a candidate, right? These two have amplitude 1. This amplitude 3, this cannot be, right? Between these two. But now I look for the shape of sine. The shape of sine is a wave, right? It's a wave starting at 0, going up, down, -1, back. It's gotta be this guy, right? It's gotta be this. Right, and notice that the period has been shrunk to 2 pi over t, a third of 2 pi, right? So this is it. Very good. So let's start by saying that this guy's shapes of sine, right, with amplitude 1, right, is the key, is this guy. So this should be y equals sine of 3x, right? So basically telling us that the graph 1 should be paired up with B, right? 1 with B. So let's write here. 1 goes with B. Next pairing. Now, let's say we want to use this guy, right? 2 is saying, let's use this other color, y equal 3 cosine of x. Where is that now? Well, 3 tells me that the amplitude is 3 now, right? Absolute value of 3 equal 3, A is 3. And B is invisible 1, right? Inside here, invisible 1. So amplitude 3 and period is equal to 2 pi over B. But B is this 1, so the period, believe it or not, guys, is just 2 pi. 2 pi. So with period 2 pi and amplitude 3, which one should be the graph? Do I have two possible candidates here to graph with amplitude 3, right? This and this. But I am dealing with cosine now, right? I can no longer have the wave shape, right? The wave shape. Instead, I'm going to look for the curvy V over a period of 2 pi, look, 2 pi period, right? So definitely should be this guy, right? Let's use green now. Maximum, then intersection, minimum, intersection, maximum, the curve V is there, right? So this guy should be the graph of y equal 3 cosine of x. So this means that number 2 should be paired up with D, right? D. Okay. Now, number 3, y equal 3 sine. 3 sine, the only one left with for this is with the amplitude 3 is this, right? So this should be this guy, right? And the period should be 2 pi over 1, 2 pi. So definitely this guy, right? So let's use a different color. So this guy, shape of sine with an amplitude 3, right? How do you know amplitude 3? Look at this 3, right? 3. Yep. So this should be y equal 3 sine of x. Definitely. So this tells us that the next on the list should be this. Number 3 is paired up with C, right? And the last one should be paired up with this, right? So y equal cosine of 3x. Notice amplitude 1, so 1, and then that's the curve V there. Cosine, the period is small, is 2 pi over 3, right? So definitely this y equal cosine of 3x, right? So this is telling us that number 4 should be paired up with A, right? This sequence of pairings, perfect match with B, right? You follow, guys? Excellent, excellent. Great. Let's move on. Let's talk about shifts on the middle line, vertical shifts, okay? But for that, I'm gonna just go over this example. It's pretty straightforward, so we should just probably consider a good example. This one, I think is a good one, number 3. What to do if they ask you to figure out the graph of this sine or cosine functions when there is a vertical shift applied to them. Vertical shift, Professor, look, I'm talking about this, right? When they are adding a real number or subtracting a real number from sine or cosine. Well, it turns out this shouldn't be difficult because this is saying that the middle line, remember I talked to you about the middle line, have been shifted up 1 unit in this case, shifted down 1 unit in this case, right? Shifted up 1 unit in this case, shifted down 1 unit. So for whenever you see this form, simply shift up or shift down accordingly. For example, here y equal 1 plus sine of x. What's the graph of this? Well, we all know that the graph of y equals sine of x is just this, right? And this is the middle line, right? Middle line. So simply shift up this middle line 1 unit. So why 1 unit? Because of it, right? 1 unit up. So if you shift 1 unit up the middle line, now the middle line will appear here, right? 1 unit up. And there they reproduce the shape of sine. Curve V. Not curve V, wave. Right? Yeah. Wave. Right? That's it. So this should be y equal 1 plus sine of x, right? You start with y equals sine of x here. And then the shift, since it's a vertical shift, should be applied to the middle line, right? Up, and then the rest follows. So clearly the first one, number 1, should be which one? Well, where do you see this guy? Well, I see it here clearly, right? Here. Very good. So definitely this guy should be graph of first one, y equal 1 plus sine of x, right? Very good. So which is saying that 1 should be paired up with b, right? Yeah, very good, very good. So next, number 2, 1 plus cosine. Similarly, right? The cosine function is this curve V. The curve V has a middle line, just shift up the middle line, right? So it's not gonna be hard to see that as a result of doing that, right? The new curve V should be this, right? Follow, guys? Yeah, so let's use another color here. The new curve V should be this, right? Yeah. Yeah, so this was the middle line. So this 1 plus cosine of x, right? So this vertical shift are really straightforward. So this is telling us that the second one, 2, should be paired up with D, right? With D. Could be up. And then what is this 3? 3 minus 1 plus sine. So instead of shifting this up, you shift this down, right? Down. So down, this guy will appear here, and then like this, right? Down. So then what shape do you get if you shift this down? Well, let's see. Y equals sine of x is just this, right? But if you shift this down, this middle line, this one, right? Middle line, down 1 unit, you will end up with this. This point will appear down here. This point will appear at 0. This point will appear down here, right? So something like this, right? Yeah, everything down, right? So your middle line should be now here. So work with the middle line, guys, because otherwise it's very tricky. This is the new middle line, right? 1 unit down. 1 unit down, middle line, 1 unit down, right? So as a result, we get this. So the new middle line should be down here, right? Yeah, this is with C. So 3 should go with C, right? And finally, 4, then, which is going to be a vertical shift of the cosine function that starts here, right? Shifted down, clearly this one, right? So therefore, this is going to be 4 should be paired up with A. Yeah. Very good. So this sequence 1B, 2D, 3C, and 4A is this, right? Very good, very good. For number 3. So this is in case, guys, they ask you to use vertical shift, right? Very good, excellent. All right, now let's talk about more variations, right? In general. So try to see if we can figure this out. I will give you the hint. They say graph, right? I'm gonna write here, graph. This one, y equal 9 halves, 9 divided by 2 here, multiplied by cosine of minus 1/3 of x. Professor, negative here, you said b should be positive. That shouldn't be a problem, guys. Hint, graph, instead this. Remember, yesterday, recall, we said that cosine of negative alpha is equal to cosine of alpha, right? We said that cosine function and secant function is reciprocal. They don't care about the sign of the angle. These two are the same, right? Since they are the same, you can work with this 9/2 cosine of 1/3 of x, right? Because they are the same, right? Yeah, work on this, try to graph this. And as a result, you should get one of these here on the, let me show you on the bottom. One of these graphs, right? We're gonna graph this. And as an extra hint, A should be equal to 9/2, which is 4.5, and B is 1/3, right? So we are talking about an amplitude, absolute value of 9/2, get that? And a period, this is going to be a little bit tricky, 2 pi over b, but your b is 1/3. So remember, when you divide by a fraction, flip the fraction, multiply, right? Multiply. So get this with this amplitude 4.5, which is 2 into 9, right? And this period, figure out which of these 4 graphs is the graph of this guy. Okay, so go ahead. I see some movement on the chat room. I see. Jing, very good, excellent, very good, excellent. Yeah, you got it, right? Yeah, very good, guys, very good. So basically, they are asking us to graph this function that has an amplitude of absolute value of 9/2. 9/2 is 4.5. Since it's a positive number, the absolute value of 4.5 is just 4.5, right? So this is the amplitude. From the middle line, the farthest you can go up is 4.5 units. The farthest you can go down is 4.5 units, right? This is what it tells you, the amplitude. Now, the period is 2 pi over b. B is 1/3. So dividing this, we're going to get 2 pi times, remember we flip this, 3 over 1, right? 3 over 1. But that is, believe it or not, 2 times 3, 6 multiplied by pi. It's a big amplitude, right? Big amplitude, 6 pi period, sorry, big period, 6 pi. So we look for one of the graphs that is showing an amplitude 4.5, a period 6 pi. Look, 4.5, this guy is a candidate, right? Look, 4.5 more or less there, up and down. This one also, right? 4.5. This one to all of them probably, right? Yeah, so that shouldn't be a criteria, but 6 pi, what is the one showing 6 pi? And also consider that we are dealing with cosine. So we need curve B, right? So perhaps we can just graph this, right? Graph this and then just go ahead and compare that with the graph. So let's just do it. So let's say we are doing this here and here now. Let's use this better. There we go. This will be good. Yeah. So now let's see if we can graph it here. Great. So now we said, right, the amplitude is 4.5. So we're gonna go up 4.5, let's say it's here, 4.5, and down 4.5, right? Minus 4.5, let's say it's there. From there, there are some horizontal lines there. This will help you. Now, up to where, what value you go? Up to 6 pi, right? 6 pi. 6 pi radians, you stop because this is gonna set how far you can go horizontally. It's called the period, right? Now, subdivide this into equal parts, perhaps there. This half into halves is other half into halves. You get this, right? And here, more or less, remember the shape of cosine. It starts with a max, right? Max, then goes into an intersection here, intersection, minimum, intersection, and max, ends with max, right? It looks like a curve V when you do this, right? So, join this with a nice curve, something like this, right? So then you have to try to identify this with one of these guys. But which one? Look, notice this guy look like that, right? And so how do you know? Well, notice, look at the period 6 pi, right? It starts at 4.5, has the curve V here, 0, maximum again, and ends precisely at 6 pi, right? 6 pi is here, as we got here, 6 pi. So that's it, right? The others, they don't do that, right? They don't have this amplitude 4.5 and period 6 pi. So this is the one that you have to take. As you can see, you don't require really the middle points, right? The x coordinates of this, this, and this, right? But in case you do, I explain how to do it, right? You take the average of these two. This middle point probably should be 3 pi, then 3 pi over 2, right? 3 pi over 2, maybe this, 3 pi over 2 average, right? Then this is a quarter, 2 quarters, 3 quarters, 3 quarters will be 9 pi over 2, right? So it's possible to get the other guys. All right, great. So now what we did this, let's talk about the most general case, okay? The most general case, and then we will talk about the tangent function. So the most general case is this, considering shifts. Suppose they give you this stats graph y equal a times sine of bx minus c, or y equal a times cosine bx minus c. There are horizontal shifts involved, right? Where a, b, and c are real numbers, b bigger than 0, right? And c also bigger than 0. Mathematicians figure out that the amplitude, as usual, will be the absolute value of this leading coefficient A here, the number up front here. Absolute value of A, the amplitude. The period will be 2 pi over B as before, right? The only new thing is this, the mathematicians call the phase shift. What's the phase shift? It's going to be given by C over B, C over B, right? Notice this is negative, this is positive. The relationship between these two guys, opposite of each other, right? Let's say you have -3, you have to write 3 here. I will explain with the example. So now, let's see an example here. Suppose they ask you to graph in general y equal -3 times sine of parentheses x minus pi. First step, quickly identify what is your A, what is your B, what is your C, right? What is your A, B, and C? So A clearly has to be this guy, right? A, this guy, your A, -3. B is the number attached to X. No, Professor, there is no number there. Well, when you don't see a number, remember there is an invisible one, right? So this is going to be B. So this guy B. 1. C, what is C? For C is a little bit tricky. Take your time when you choose C. Look, showing here minus pi, right? Minus pi is being shown here, right? But instead, you're going to take the opposite. So you take pi. In case they show you plus pi, you see will have to be negative pi, right? See, that's how it works. Yeah, all right, so now we have amplitude. For the amplitude, we have to take the absolute value of A, which is the absolute value -3, which is going to be +3, right? Remember, the absolute value removes the sign. Period 2 pi over B, right? Over B, but B is, in this case, 1. So 2 pi over 1 is 2 pi, right? Phase shift is, remember, C over B, right? C over B. But C, we're saying is pi. B, we're saying is 1. So the phase shift should be just 1 into pi, which is pi, right? Pi. Now, how you graph this, right? How you graph this on the XY coordinate system? Well, start, I'm going to write it here, right? Start at the phase shift, no longer at 0, because there is a phase shift, right? There is a horizontal shift. So start there at this guy, at pi. Start at the phase shift, whatever is your phase shift, start there. Start at phase shift. Okay, and what is our phase shift here? Is just this pi, right? This pi. You start there. And end at phase shift plus period. Phase shift plus period. Right? So you take a period, but it's starting at the phase shift, right? So the phase shift, this guy is pi. The period is 2 pi, right? So phase shift plus period, 3 pi. So you will end your graph at 3 pi. You start at pi, you end at 3 pi. Very good. So in here, allow yourself some shift here, call it pi, right? Again, I said the horizontal scale does not matter. What it's important is the main shape, right? Start there, and you're gonna end somewhere where at this 3 pi, right? 3 pi. So let's take somewhere, right? 3 pi here. It's pi, 3 pi. All right, great. So now the amplitude is 3. So how far you can go up? 3 units, right? So let's say this is 1, 2, 3. Let's say there 3. Similarly here, 1, 2, 3, let's say it's here, -3, right? This is telling you that your graph should live within this strip, right? No matter what, this strip, it should be inside. The graph of this function over a period should be inside this horizontal strip. Up to where? Up to this 3 pi, right? No longer, because this is determined by the period, but it's starting at here, right? So notice now that the rectangle that I had before has been shifted pi units to the right, right? So inside this rectangle is where we're gonna graph over our period. Now, remember, once you have the starting point, the end point, divide that into parts. So take the middle point here, divide the left half into 2, the right half into 2, let's say it's there, right? And try to recall the shape of the graph that you are dealing with. We are dealing with sine, right? With sine. So we are supposed to use a wave shape, right? Remember, sine starts at 0, sine of 0, 0, that then goes up here, right? Max. So start with intersection, then max, then goes back to intersection 0, right? Minimum, mean, and then closes with intersection 0, right? Intersection 0, great. Like a wave, right? Like this. But now let's be careful with this wave, right? Because notice that here in front of this number 3 is a negative sign. So this is telling me that I have to take the reflection of this guy, right? The reflection because of this negative sign. So what I'm going to do is I'm going to draw this using these continuous lines first, because this is not going to be the final graph, right? This is going to be just a reference for me to come up with a final graph. So I'm going to use these continuous lines for the graph, right? And the final graph will be the reflection of this, right? The reflection of this. So the final graph should be this, right? Follow, guys? The reflection about the x-axis, right? There we go. So this is going to be the graph of y equal -3 sine of x minus pi. Okay. Very good. Right? This was the one without the minus, but with a minus is this, right? You follow, guys? Yeah, and again, if you are curious about what should be the x-coordinate of this point, the x-coordinate of this point, the x-coordinate of this point, you can find them, right? In case you need it. Look how I get this value here. Average pi and 3 pi. Pi plus 3 pi, 4 pi. 4 pi divided by 2, 2 pi. Right? This is this guy. Average is 2. Pi plus 2 pi, 3 pi. Divided by 2, 3 pi over 2. But this 3 pi over 2 is a quarter, right? A quarter. 2 quarters, 3 quarters, right? 3 quarters. 3 of this. 3 times 3, 9. 9 pi over 2 here, right? Yeah, work that way. It's possible to get these guys. Get the half first and then the play with the quarters. 3 quarters. 3 of these. 9 pi over 2. That's it. Yeah, but let's be careful here. I gotta be careful, very careful here. This is if this will be at 0, right? Yeah, let's be careful here, guys. This has to be taken care of because we have a shift now. We have to be careful. We have to average these two. It's better, right? 2 pi plus 3 pi, 5 pi. 5 pi over 2 would be there. Yeah, because the other technique works if this is 0. So this one 5 pi over 2. Now it's good. 3 pi over 2, 2 pi, 5 pi over 2. Excellent. Yeah, very good, guys. So this is how you deal with shifts, right? With shifts. Now I want you to work on something. Looking back, going back, you look for this in the among the choices, right? Where is that? Well, we will practice now soon. So let's go to the worksheet. Let's work on something here. So you have, let me see something. And then we will go over the graph of tangent. Yeah, let's see one that shows shifts. I see someone here. Can you try this? This one we shift. Yeah, try this one. Try to figure out what is the right pairing here. Okay. Yeah, sometimes if you prefer, you can just shift this graph, the graph of sine of x, pi over 2 units to the right and figure out which one is this, right? Shift this cosine of x graph pi over 2 units to the left, right? Because this guy is just 1, right? So if you want to do that, if it's easier, figure this out following that. Number 3. Yeah, try to do number 3. We'll move on. Hmm. Yes, a hint, I can start this with number 1. Number 1, y equal sine of x minus pi over 2, right? Compared to y equal sine of x, it's just a horizontal shift, right? Shift this guy, y equal sine of x, pi over 2 units to the right, right? Why to the right, Professor? Because it's opposite to what our intuition tells us here, right? For minus is right. So shift this pi over 2 here, pi. Yeah, maybe I should graph it nicer. Zero, pi over 2, pi, 3 pi over 2, 2 pi. Shift this graph, pi over 2 units to the right, meaning this guy will appear here, this guy will appear here, everything is shifted, right? Shifted. And then you should get the graph of that guy. This point, for example, will appear now here. This other point, everything is shifted, right? This peak appears here, pi units to the right. So this is gonna be pi over 2. Here's the hint. It starts there, the wave, right? So repeat the wave there. Yeah, so everything moves. This point moves here, right? Everything moves. This is y equal sine of x minus pi over 2 compared to this one, y equals sine of x, right? So clearly one should go with the one that is shifted. This one I think is this. Shifted sign, shifting sign, you get this, right? Very tricky. Yeah, one should go with C. Okay. Yeah, correct. Yeah, then continue with 2. A cosine of x plus pi over 2 is the graph of y equal cosine of f shifted pi over 2 units to the left, right? To the left. To the left. So which one is that? Well, remember cosine originally looked like this, right? Like a wave. But if you shift this pi over 2 units to the left, this guy will appear here, right? It's very tricky to catch it, right? But this guy will appear here. This guy will appear here, right? This guy will appear here. I think it's this, right? Yeah. Yeah, this should be the graph of y equal cosine of x plus pi over 2, right? Shifted pi over 2 units to the left, right? So definitely 2 should go with A. Yeah. 2 should go with A. 3 is the graph of sine of x shifted pi over 2 units to the left, right? To the left. So try to figure that out. Yeah, okay. So definitely this is originally the graph of y equals sine of x, right? But if you shift it pi over 2 units to the left, this point will appear here, right? And the new graph should be this, right? So again, this point appears here. So this is the shift, I think. Yeah. Okay, again, this point goes here. This point goes here. This is y equal sine of x plus pi over 2. Great. So this will be the number 3. 3 should go with B. And the last one, 4, which is the graph of cosine of x shifted pi over 2 units to the right, to the right. Look, this is the graph of cosine original, right? If you shift this to the right, pi over 2 units, this point will appear here. This point will appear here, right? So you should get this guy, right? Yeah, very good, very good. Pi over 2 units to the right, So it will be here, right? Let's draw it in this color. Yeah, there, right? To the right, pi over 2 units. So this should be 4D. So therefore, this should be 1C, 2A, 3B, 4D, this guy. Yeah. Very good, guys. Now, let me give you another one that is simpler, just to directly graph the function. I think it's here. Can you try this? And for this, we may have to follow the technique, right? Remember, recall, I would write recall. If you are trying to graph y equal a sine of b times x, the amplitude is the absolute value of a, and the period is 2 pi over b. No shift because shift is 0, so don't worry about the shift. It will start at the origin of the graph, right? So try to do this. And once you are done, identify your result with one of these in the bottom. So this one, this one. I will write the question here. Graph y equal -3 sine of 1/2 multiplied by x. Yeah, this is one of these 4 graphs. So can you figure this out? 8. Huh? Mhm. Yeah, graph this and identify with one of those. Yeah, try guys. And remember here, when you divide by a fraction, you are supposed to multiply by the reciprocal of the fraction, right? Maybe also as a hint, I should say that in this case, A is just -3, right, from here, and B from here, 1/2, right? So find your amplitude, your period, using these formulas, and with that, figure out what is the graph, right? Mm-hmm. Yeah, maybe we should include here coordinates so we can, yeah, great. Yes, students post the answers here. Let's see, let's check. Number 8. Jinjin. Yeah, you made my day. Very good, Jinjin. Very good. Excellent, excellent. Yeah, very good, guys. Look, amplitude is absolute value of A. So absolute value of -3, which is going to be equal to 3, right? So we got the amplitude. 3 up, 3 down from the middle line. Period 2 pi over B. But our B happens to be 1/2. Remember, when you divide by a fraction, if the fraction is a divisor, you end up multiplying by the reciprocal of the fraction, right? Which is going to be 2 over 1. 2 pi times 2, 4 pi divided by 1, 4 pi, right? So I'm looking for a graph with period 4 pi with amplitude 3, right? Amplitude 3, period 4 pi. So this looks like a candidate, right? Amplitude 3, 3 up, 3 down, if 1, 2. But now let's look at the period 4 pi. Which one has period 4 pi? Probably we can just graph it and then match it, right? With one of these 4. So here, amplitude 3 is telling me that I'm supposed to go 1, 2, 3, 4 up, and then 1, 2, 3, 4 down, right? 4 down. So 4 here, minus 4 here. I'm starting at 0 because there's no phase shift, right? No phase shift. So then horizontally, I have to go as far as 4 pi, right? Because that's the period, 4 pi. So let's say 4 pi is here. Let's say 4 pi, let's put it there. Okay, so now when you draw this horizontal line, it means that the graph is going to be inside this strip, right? Inside this strip. Up to where? Up to here, this 4 pi. So stop the strip there. Now we got this rectangle. Divide the rectangle into equal parts, right? So here, then subdivide this rectangle on the left, subdivide the rectangle on the right. This will help you to do the drawing here. Try to recall the shape of sine, right? The shape of sine, remember, is a wave shape, right? So it starts at 0, sine of 0 always 0, right? Then goes up to a maximum value. It starts with an intersection, then maximum value, comes back to intersection, 0, then minimum value, right? Minimum value, and then ends at the intersection, closing its cycle, right? So connect these dots with the smooth curve, right? Smooth curve means no corners, no sudden turns, right? Like this, enough. Very good, right? Like this. All right, that's the graph, right? try to see which one is showing this, right? These middle points, again, if you're interested in them, 4 pi, the half between 0 and 4 pi, 2 pi, right? And if you're interested in this, take the average of these two, 2 pi plus 0, 2 pi divided by 2 pi. This is a quarter. Right now, I can use my technique of the quarters. Or if you prefer averaging, these two also works. 2 pi plus 4 pi, 6 pi divided by 2, 3 pi, right? We use the quarters, 1/4 is pi, 3/4 is equal to 3 pi. So this is it. So look for this, and clearly the one that is showing this is Sine. Yeah, but turns out this is there's a minus there, right? Minus, be careful. So therefore we have to use discontinuous lines for this, because we have to take a final reflection here, right? Reflection. So taking the reflection, finally, the final graph should be this, right? The final graph should be this. Basically this. Maybe we should use a different color. Yeah. Taking the reflection, right? Up here, smooth again, down here. So this should be the graph of y equal minus 3 sine of 1/2 of x, right? That's it. And this clearly matches with this part, right? And I see very tricky because you're supposed to extend it to see it. I think, yeah, this is this, right? So excellent, guys. Very good. Now let's talk about the tangent function, right? Tangent function, to close this type of functions. First, you see the tangent function is not continuous, doesn't come all in one piece. You will see it's broken, but it still exhibits a period. I will show you. Graph of other trigonometric functions, graph of tangent function. How do you graph the tangent function? Y equal tangent of x. Let x be 0, for example. Tangent of 0 is sine of 0 over cosine of 0, 0. So we get our first point here, 0 with 0. Tangent of pi over 4. Tangent of pi over 4. Remember, in the unit circle that I asked you to have handy, you can see pi over 4 is here, right? 45 degrees pi over 4. Sine is square root of 2 over 2. Cosine is square root of 2 over 2. So tangent of pi over 4 is sine over cosine. The square root of 2 over 2 divided by itself. The square root of 2 over 2 has to be 1, right? 1. So this guy, 1. Okay, 1. Yeah, and for the ones who were not here yesterday, this is an important sheet, the sheet of the unit circle. We're going to use it a lot. So in case you want the link, it's in our website already, right? But in case you want the link, here it is. It's very useful. The sheet, here is the link. You can save your chat and you will get a link, or you can click in there. All right, tangent of pi over 4, 1. What is tangent of minus pi over 4? Recall, yesterday we showed the tangent of minus alpha. It's just this. You take the negative sign outside, minus tangent of alpha is equal to tangent of minus alpha, right? So if tangent of pi over 4 is 1, following this, tangent of negative pi over 4 should be negative tangent of pi over 4, which is 1, so minus 1 here. So pi over 4, let's say, is here, should be paired up with 1. Let's say here. Okay, 1. So 1 here. And tangent of pi over 4 negative should be paired up with negative 1. Let's say negative 1 is here. Negative 1, so here, right? So we have more points. Now, what happens at pi over 2 and at minus pi over 2? Well, if you try to get this on your calculator, right? Or even in the unit circle, let's go back to the unit circle, right? Notice if you go towards pi over 2, sine increases, in size, right? But cosine decreases to 0, right? So sine is increasing because sine is the second coordinate, but cosine is decreasing. So sine will be a big number, cosine will be 0. So if you divide a positive number by 0 or a close number very close to 0, it's a huge number, right? It's undefined, but mathematicians consider that to be plus infinity, right? Tangent of pi over 2, positive infinity, because division by 0 is undefined, but we know it's a big number or close to a big number, right? So this one infinity, positive. Same idea here, since tangent of minus alpha equal minus tangent of alpha, if this is infinity, this has to be minus infinity. So for pi over 2, the tangent function blows up in the sense that the output value should be a huge, huge number, positive infinity. And same idea here for the output value for tangent of negative pi over 2. The tangent of negative pi over 2 is in theory undefined, but then it approaches to a very big negative number, right? So negative infinity. So it's going to be somewhere up here, the output, somewhere down here, the output, right? So if you connect these dots, considering the end behavior of this function, right, towards pi over 2, towards minus pi over 2, you're going to get this curve, you will see. It's going to look like a chair, Again, smoothness is required, right? So smoothly go through those 3 points. Yes, erase this. Smoothly. So nicely over these 3 points. And it's going to look like a chair where you sit, right? Okay. So this is the shape of the tangent function over a period, okay? So this shape, chair. And therefore, this should be a period, because it turns out after pi over 2, it will repeat itself, a chair to the left and to the right. To the right here, to the left here, the chair will repeat itself. Mathematicians often put an arrow here to indicate that this continues. The curve gets closer and closer to infinity here, closer and closer to this vertical line, never touching it, negative infinity here, right? And then this chair will repeat itself to the right, to the left. Let's do it here, this way, right? And here too. So this is the main shape of the graph of y equal tangent of x, okay? So we focus on a period which is now shorter than the period of sine and cosine. You will see the period will be this distance, right? Pi over 2 to the right, pi over 2 to the left. So together, right, on the overall, pi over 2 to the right plus pi over 2 to the left, pi over 2 plus pi over 2 is pi. So the period of this tangent function should be pi, not 2 pi. It's smaller than the period of sine and cosine, right? Pi. It takes just pi radians for the function to repeat itself, for these chairs to repeat themselves, right? Yeah, great. Now, I'm going to write a note here because this question is very often asked. Professor, what about the amplitude of the tangent function? Notice this is growing without bound in this direction, no upper bound. It's decreasing without bound in this direction, no lower bound. So there is no amplitude, right? No amplitude. So tangent function does not have amplitude, does not have amplitude. It just has a period, right? Amplitude, because it is not bounded, because it is not bounded, right? It's neither bounded above nor bounded below, so not bounded. All right, so basically, in general, if they ask you to graph this type of functions, y equal a times tangent of bx, where a and b are real numbers and b greater than 0. In case it's not, you can pull out a sign, remember? Then mathematicians came up with just one formula that will tell you what is the period. Period pi, the period of the tangent function, divided by b, right? Divided by b, because this b acts as a factor that will compress horizontally your graph, right? Yeah, great. So example here, suppose they ask you to graph this function y equal 3 times tangent of 2x. As usual, quickly identify the values of a and b. This will be clearly your a, right? 3. And your b will be this guy, right? 2. From there, use the formula, right, for the period pi over b, right? But b in this case is just 2. So the period is pi over 2, right? That's the period. So we know that this tangent function, when graph, looks like a chair where we see it, right? Kind of resembles the graph of the cubic function, right? Y equal x cubed. That type of chair, right? So this is the period. But now, in order to graph this easily, guys, I want you to follow this strategy kind of. The period is pi over 2, right? So you're gonna go, hint. You're gonna take, take 1/2 of period, which is 1/2 of the period, in this case is pi over 2, right? Which is gonna be 1 times pi, 2 times 2, 4, pi over 4, right? 1/2 of the period is pi over 4, and go that amount of radians, pi over 4, half of the period, to the right, from the center to the right. From the origin, go half of the period to the right, and then half of the period to the left. So maybe we should put pi over 2 units, so I don't want to confuse anyone. Pi over 4 units to the right. Units to the right. And go pi over 4 units to the left to set the vertical asymptotes, right? So look, from the center, go, let's say this is pi over 4, right? Radians to the right. And pi over 4 radians to the left. You set the other vertical asymptote, right? And there, considering these two vertical asymptotes, then draw the chair there, right? Draw the chair there. So the chair should be asymptotic here, going through the origin, because remember tangent of 0 is 0. And then asymptotic here as well, right? This is it. This is the graph of y equal 3 times tangent of 2x, right? Of 2x. We use just this number, right? You may say, Professor, what happened with this number 3? That number 3 is just stretching this original chair, right? Stretching it vertically, right? Vertically, if you want to make sense of that number 3, it's stretching, right? But it's a chair, right? And it's enough to graph what happens over a period, right? Over a period. And it repeats itself to the right, it repeats itself to the left. But this is important, this part, right? To show that the period is equal to pi over 4 to the right, pi over 4 to the left, together, twice pi over 4 equal pi over 2, right? So this is the period. Period equal pi over 2. Yeah. Very good, very good. Now, can you try a couple of exercises that I have here on the worksheet? But before we go to the worksheet, since they're very straightforward, I'm going to give you this other example 2 to conclude this part. Example 2. What is they say graph y equal 2 times tangent of 3x. Negative here, negative, with a negative sign. Well, again, right, you quickly identify A to be now negative 2, B to be 3 now, right? And turns out we use just one formula, which is this, right? Period, which is pi, the period of the tangent function, divided by b, right? Divided by b. But in this case, b is 3. So pi divided by 3 is the period. Now we follow the hint, right? Go 1/2 of pi over 3, which is equal to what? 1 times pi, 2 times 3, 6, pi over 6 units to the right from the center, right? And pi over 6 units to the left, right? That way you're going to construct your asymptotes, right? Your vertical asymptotes. And with that, you should be able to graph this tangent function, right? Yeah, let's say this is the XY coordinate. We're saying the hint is from the center. Now go pi over 6 units to the right, right? Let's say here, pi over 6. To the right, pi over 6 to the left. Pi over 6 to the left, let's say here minus pi over 6, right? And there, draw your vertical asymptotes. This will be the vertical asymptote of your tangent function, right? Now, we're supposed to draw the chair, right? The chair, but allow me to draw that chair using these discontinuous lines first. I will tell you why. Discontinuous lines. Why? Because notice that in the original question, there is a minus sign here, right? Minus. So in the end, you are supposed to take the reflection about the x-axis, right? About the x-axis, the reflection. So taking the reflection, the final graph should be this, right? Take the reflection of the chair, right? This should be the graph of y equal -2 tangent of 3x, right? Yeah, the reflection, right? Take the reflection. Take the reflection about the x-axis, right? Yeah, very good. Okay, guys, try to do this quickly to finish. Let me go back to the worksheets, okay? There were a couple there hanging. I think it's this. Yeah. These two. Can you figure this out? The first one is, look, y equals negative tangent of x. Can you graph this? Graph y equal negative tangent of x. Use the reflection principle, right? You know that tangent of x is a chair where you sit, right? But take the reflection of that about the x-axis. So which one should be the one? And be careful there because probably there are two candidates, right? Or if not, yes, probably it's clear which one it is once you do the reflection, right? Let me check. Let me check some. Jing, very good, excellent, right? Yeah, very good, Jing. We know that the graph of tangent of x, and this is something that you should really memorize, guys. This function y equal tangent of x is very useful, You're gonna see a lot this function. Its graph, the graph of its basic form is this, right? Let's do it nicely there. This chair where you sit when you're tired, right? This chair that kind of resembles the graph of y equal x cubed, right? It's this chair, we know that. But now it turns out this is the graph of y equal tangent of x. They are asking you for the graph of y equal negative tangent of x. So you take the reflection. So this part that is positive becomes negative, right? And this part is negative becomes positive. So you get another chair, but well, what I call a decreasing chair from left to right, right? This chair is increasing from left to right, this is decreasing. So this should be the graph that we're looking for, right? Y equal negative tangent of x. And this clearly, the only one that is showing that is this, right? There we go. And you may say, Professor, that there are more chairs there. Yeah, but I hope, guys, it's enough to see what happens with one chair, because this is what happens over the period. The reds are copy and pastes of this, right? To the right, to the left. Here it's another chair. If you complete it, right? They didn't do it, but chairs to the right, chairs to the left. Great, excellent. Now I want you to try this other one. 3 times tangent 2 to the x. But this one, I think we probably did it, right? Yeah. 3 times. Yeah, this is the one that I just did, right? Yeah, but I still want you to identify the answer, because it's kind of tricky to identify which one. There are two candidates there. I want you to kind of, I'm going to write the question here, right? In the top so everybody can see. This is question number 10. Graph y equal 3 times tangent of twice x. Yeah, this is it, I think. Excellent, yeah. Could you identify which one is this, right? There are two candidates there, right? Identify which one is the answer. Can you? We did it in the notes, right? But I want you to identify, because it's going to really be tricky there. Yeah, go ahead, go ahead. Okay, let's do it together, right? Remember, we did it and we explained that this guy, since there's a 2 here, A is 3, B is 2, right? And the period pi over b, so it's going to be pi over 2, right? That's the period. So we're going to take a half of that period, pi over 2, which is pi over 4, right? And we go to the right, pi over 4, and to the left, pi over 4, right? That was a hint. I see, student. I'll figure it out. Jing Jing. Yeah, let me check, Jing Jing. Let me see. Close. But as I said, it's between this and this. Which one? Look, this is going to be the graph, right? Yeah, it's tricky. These two seem to be serious candidates, right? But how you really don't. Great. Very good. Excellent. Yeah, so is this chair, right? Is this chair half of the period to the right, half of the period to the left? Well, which one? Look, these two seem to say the same thing. Well, notice, right? If you continue doing this, right? This is 0, right? Another pi over 4 will be here, right? Another pi over 4. So twice pi over 4 is pi over 2, right? Pi over 2. And then after pi over 2, if you add another pi over 4 here, that's pi over 2, 1 pi over 4, 2 pi over 4, 3 pi over 4, 3/4, right? 3 pi over 4 here, right? Will be the next, right? So the next chair on the right should be this, right? You follow, guys? The next chair on the right. And which one is saying that? This, right? You see? Pi over 2 here. You see this point? Maybe it's worth it to mark it. This point, pi over 2, is this, right? And this point, another color. This is, of course, this, right? In both, right? In both, right? But this one is not saying that this curve, the second chair, should go through pi over 2, right? Following this reason, right? Pi over 4, 2 pi over 4, pi over 2, 3 pi over 4, right? So in some cases, you might have to complete, not complete, to consider a couple of chairs to figure out, you know, which one is the right one, right? So this is telling us. Follow, guys? You can do it to the left or to the right, right? Did it to the right, figure out the second chair should go through pi over 2, right? This one doesn't. This is the flaw here, right? Follow? Okay, guys.